All right, we got the first look at limits, and limits, that's a calculus concept, so this is some pretty sweet stuff. Basically, the only difference is a shifted geometric sequence, which we're going to talk about. It just includes an added term in the recursive rule, and we'll see how this affects it differently. So, I just got an example up here. I mean, I could simplify this guy too and say u sub n equals 0.85 times u sub n minus 1. But there's just something added or subtracted at the end, so I could say like plus 14. Well, that shift, that adding or subtracting something at the end, sometimes causes it to limit out, or have a what we call a long run value. And we'll take a look at that here in just a second. So here's an example where we actually see a limit, also known as a long run value. So it says find a long run value or limit for each sequence in exercise 1. What it means is, it's almost like where this graph starts to level out. Kind of, where is this leveling out? That's what I'm trying to think of, leveling out. And so we have the initial term of 800, okay, and our initial spot is the 0th term in this case. In our recursive formula, I might simplify this right away, equals 0.95 u sub n minus 1 plus 16. I can type it in either way with it simplified or with the parentheses originally. And I just so happen to have this typed into my calculator already. So just make sure that you're in sequence mode like usual. Go to your equation editor. Always check, right? The 0th term is our initial. So I can put 0 in up top. And then down below I put in 1 minus 0.05 in parentheses, okay, or you can just put 0.95, that's perfectly fine, times u sub n minus 1, parentheses, plus 16. And then our initial term was 800. Okay, so I'm going to go ahead and I'm going to look at my table. So the long run value, I'm going to look to see when this levels out. So if I look here, it's got 800, goes down about 25. Now it's starting to go down about 20. Okay, it's going down less and less. It's kind of starting to level out some. But it's not giving me a consistent number. It keeps going down, right? This might take me a while if I keep scrolling down. What might be easier? I could still start. I'm going to start out 1 just like I did. Or actually the 0th term because that's where I started. But maybe I want to count by like 10s or 20s or something like that. So that's what I'm going to do. I'm going to count by 20s. Because now I can get through my data a little bit quicker. And I'll go back to my table. All right, here we go. So the 0th term is 800. The 20th term is 492. The 40th term, okay. Oh, now we can see it's leveling out. It's getting closer, closer. It's thinking, it's thinking. Uh-oh, we're starting to see where it's leveling out at. Look at that. Every 20 terms it goes up, it's barely going down some hundreds. Can we tell where it's leveling out? You should be able to. This is leveling out at 320. So if I made a graph of this guy, up at 800 is where we started at, right? So 400 would be kind of right in the middle here. And it looks like as I get to, so about the 140th term, that's where it's leveling out. So if I counted by 20s here, and I said that was the 140th term, this is like the 40th. At 320, this is starting to level out. So it kind of came down like this, and now it's leveling right here. So that's its limit, right? Its limit is at about 320, right? The long run value. See how that works out? So it's like, where does your graph level out? Where is its limit, right? It's not going anywhere below 320. And where do you see this in real life? Is with medicine. And like if you're going to be a pharmacist someday, you kind of have to have an understanding of limits and why this works and how your body operates. So for example, in number 9 in your assignment, it says Jack takes a capsule containing 20 milligrams of prescribed allergy medicine early in the morning. Okay, that's my initial term. I'm going to start writing this out. So I got my initial term, 0 days have gone by, he's got 20 milligrams. By the same time, a day later, 25% of the medicine has been eliminated from his body. Jack doesn't take any more medicine, and his body continues to eliminate 25% of the remaining medicine each day. Write a recursive formula for the daily amount of this medicine in his body. Okay, we'll do that before I answer the question. Okay, so the recursive use of n equals, well, is it 0.25 times u to the n minus 1 sub n minus 1? No. Remember, it's decreasing. Be careful of the wording. It's decreasing, right, by 25%. Okay, it's eliminated, so it's going down that much. Anytime it says like it's going up or down, then you have to subtract from 1. So 1 minus 2.5. So just be careful of how things are worded. And then times u sub n minus 1. Or you can simplify it. Some of you can see that right away, and you know that you need 7.75. Because really, each day, the medicine is like 75% from previous, right? So if there's 20 milligrams the first day, 75% of that is still left, so that'd be 15 milligrams, because it drops 25%. And then lastly, I need my third step, when n is greater than or equal to 1. All right, now it asks, when will there be less than 1 milligram of the medicine remaining in his body? Well, the best way to do this, go to our graphing calculator, and let's go ahead and get this typed in. So now, I got 1 minus, and I can just edit what I just had here, 0.25, and I still got u sub n minus 1. Now let's get rid of that extra stuff I got. And my initial term now was 20 milligrams. Not my. And table set, let's just start at day 0, right, when there's an initial amount of 20 milligrams, and let's count by ones, so go to my table. So yeah, like we said, 15 milligrams in day 1, and 1 day later, 2 days later, 3 days, 4 days, 5 days, 6 days, 7, 8, 9, still not less than 1, still not less than 1, less than 1. 11 days later, it takes 11 days to get less than 1 milligram of medicine still in his body. Okay, so you can see how that would work in real life for a pharmacist. You got to realize, like when you take medicine daily, you're putting medicine back in your body, and your body's eliminating a certain percent each time. Okay, that's where recursion kind of works in real life.